Welcome back to Zurich PASC 2024 and our continued spotlights on the minisymposium. Joining me here on stage, we have Andreas Vitalis, and you've been organizing a minisymposium on workflows in drug discovery. Tell me more about it.
So our workflow that we're interested in is the one where you try to come up with new ways of finding drugs for interesting targets, so pharmaceutical applications. And our goal was basically to see whether there are things that are done in academia that aren't transferable yet into industrial settings or into the pharmaceutical industry, because they might be too technical to adopt, they might have too specific domain knowledge that they require. And so to facilitate this transfer of information, we decided to invest in this mini-symposium and get originally speakers from, of course, academia and industry. And we had some cancellations, so we ended up with a purely academic meeting, but that's how it goes sometimes.
Yeah. So this happens to be a topic that's very dear to my heart too, right? And it spans everything from low-level details about, say, free energy calculations to docking, handling massive data. Are you going to solve this entire problem, or are you focusing on a part of it?
So the mini-symposium was trying to get the whole view, all the way from really detailed free energy methods, which were based on molecular dynamics, which you, of course, are one of the lead experts on, all the way up to very coarse models, so machine learned scoring functions for drug discovery. So we tried to connect everything to see what is the panel of methods that are. Of course, we didn't cover all of them, far from it, but we tried to get a good view of what the range of things are that are currently like on the cutting edge of the academic side. And also another interest of us was to see whether this field can be standardized more, especially in the industry setting, because reproducibility is a big concern, and these campaigns, they end up being engineering campaigns and not science campaigns, and so they tend to involve a lot of choices, and these types of choices are often driven by very individual biases, right? And then to make them into like a fair type of model is very hard.
And I was going to ask about that. Fair is, of course, exceptionally important for data, right?
Yes,
and I think historically in Manifest, we focused a lot on workflows as a way of having the workflow. But it's just as much a data flow, right? And how we handle and archive data. Is it something you're working on?
Yes, absolutely. So one of the things that we presented was our own tools, which are a way to encapsulate this type of information in more standardized ways. So specific SQL databases for storing trajectory information, for storing small molecule information, that provide a strong link between metadata and the actual data, which is the biggest obstacle to interpreting these data, because if they're just sitting there by themselves, they're really hard to work with.
So that sounds cool. So during the symposium, what was the main take-home message for you? Anything surprising or unexpected?
No, I think we realized again that the biggest obstacle in academic research is that academic researchers are forced to work partially in an island mode, because there's never the resources available to go bigger, like to invest in software, unless you have a big grant that supports your software, like Bromex had for a long time. So the biggest problem is probably that this transfer cannot be coming from academia. So industry has to come harvesting, and this is where the technical bottleneck of not having expertise with a method is an issue, and that was one of the goals of the symposium. But as I said, we were lacking on the industry representation.
Right, and an important part, these symposia are meant to be seed ideas and everything. So based on this, what are you going to go back home and do now, or what should people in general do to help advance this?
Right. So the most important thing we're going to do is we're going to complete the thing that we're working on to release it, which is basically ready, and so that it can become public. And then we're hoping, and this is where I just said that we're hoping that industry picks up on it and show some interest in it, and then if we can get it like inserted somewhere, then it might become a tool to standardize also industrial workflows. But that remains to be seen.
So if I or our listeners here want to learn more about this specific workflow, where do we find it, or the information?
So we all work in the group of Amadeo Kaflic at the University of Zurich, so the best starting place for that is our website at biochem-kaflic.uch.ch. And that's where you would find the core information on this topic. Otherwise, direct communication is always appreciated, so send us emails. We're very happy to respond, and also to requests that you might have.
Wonderful. Thank you so much for joining us, Andreas, and thank you for listening.
Thank you very much, Eric.